Why do op-amps oscillate? Due to parasitic elements. Imagine a perfectly designed circuit, but suddenly it starts to hum or squeal without any clear reason. That unexpected noise is often caused by something lurking inside the circuit itself. Today, we are going to uncover why operational amplifiers sometimes start to oscillate because of tiny, hidden elements called parasitic components. These are not part of the original design but are always present because of how circuits are built and how components behave physically. Parasitic elements include unwanted resistances, capacitances, and inductances. They come from the physical layout of the circuit, the wiring, and even the chips used. For example, every wire and component has a tiny amount of resistance and capacitance. These small effects might seem insignificant, but at high frequencies, they can cause big problems. When an operational amplifier is working, these parasitic elements can create unintended feedback paths. Oscillation happens when part of the output signal loops back to the input with the right timing and phase. This positive feedback makes the circuit amplify itself uncontrollably, leading to unwanted oscillations. Parasitic capacitance between the input and output terminals can couple signals back and forth, especially at higher frequencies. If the phase shift caused by these tiny capacitors and inductors reaches a critical point, the amplifier can start to oscillate. Another cause is the feedback network itself. If the feedback components are not chosen carefully, they can introduce phase shifts that push the circuit toward instability. This is especially true if the phase margin, which is the buffer before oscillation begins, becomes too small. When the phase margin shrinks, the circuit is more likely to start oscillating. Supply bypassing is also important. If the power supply is not filtered properly with bypass capacitors, noise can enter the circuit and cause it to become unstable. Without enough bypassing, the power supply can inject signals that trigger oscillations. Driving a capacitive load without proper compensation can also cause trouble. Capacitive loads introduce additional phase shifts that reduce the phase margin further. This can make the op-amp more prone to oscillate. To prevent these issues, engineers take specific steps. They use short wiring and careful component placement to reduce parasitic capacitance and inductance. Adding a small resistor in series with a capacitive load can help stabilize the circuit by reducing phase shifts. Properly designing the feedback network ensures enough phase margin is maintained. And using adequate bypass capacitors on the power supply filters out noise. By understanding how these parasitic elements behave and affect the circuit, engineers can design more stable and reliable operational amplifier circuits. This helps keep your electronics working smoothly, without unwanted noise or oscillations.